Hey everybody, excited to chat today about, is it this thing? Oh yeah, great. Excited to chat today about this concept of the software factory and a little bit about what we're doing. And so when I talk about the software factory, I always like to reflect on how insanely quick this entire field has actually evolved, right? 3.5 years ago, basically. We started 3.5 years ago, and back then, autocomplete was basically the only sort of like known workflow for introducing AI into the at least like dev tools that were let's just say like what we now consider to be standard like agentic or semi-agentic LLM based workflows. And so autocomplete moved on to chatbots moved on to agents, and agents are now moving into software factories. So what does that actually mean? Well, if the slides were ordered well and that I had sent, my bad, I would be talking about exactly this, which is that a software factory is really this process where signals flow into sort of your system, right, or your business. These signals could take a lot of different forms, but traditionally, if you're building like, let's say like a piece of software that helps people like manage information, or you're like a school system and you're trying to build some software for that. Maybe you're a financial services firm and you're doing a bunch of stuff to manage transactions. The signals that you're ingesting might be things like customer feedback, internal data telemetry, an executive saying we're going to pivot, right? Like it could be a lot of different things. And all of these signals today, human beings actually triage themselves in their heads, and it's almost never explicitly represented in any like real system. At that point, those signals are then sort of ingested, and luckily if you're like operating on signals for things like a bug or an error, you hopefully have telemetry for that. But ultimately that triage process is very human driven today in almost all organizations. Then you go and you start to plan, and really that's the first time that you start to encode any of this information anywhere. You'll typically do this in something like Jira or maybe Notion, maybe you're doing it in Confluence, but either way, this planning process tends to be fairly unstructured at most organizations, and then you start to move into actually writing the code, validating the code, shipping, deploying, and ultimately with deployed monitored software, it starts to generate more signals. So what's interesting is this implicit feedback loop exists at almost every company building software, and yet an explicit model of this does not really exist anywhere. And so what we've sort of found is that what's interesting about this is that if you think about the hard part of this problem, coding is just not the hard part. It's basically, in fact, the easiest part of this problem. And in fact, all of the other things around actually writing code are the hard part, the part that leads to mess. And I think that when a lot of people think about sort of the velocity aspect of, you have an AI CEO or saying like, oh, AGI's here, it's like 6 months away, you're gonna see 100x productivity, and then you yourself have not seen that at your company. A lot of people are sort of asking the question, why is that? Well, really it's because you're actually only AI-ifying like one narrow slice of this process, and then a lot of it remains a very human-driven, synchronous workflow where you go and you say to a machine something that basically looks like autocomplete. I want the thing, you give it back to me. I send you on a task, it comes back to me, right? And so what we want to do is we want to say, how do we basically design a system that allows signals to flow all the way to deployed software without human intervention, right? And so when I say without human intervention, I don't mean without humans at all being involved in the process, right? And that sort of leads to a lot of the questions that I think people are asking right now, which are probably very hard to read on this slide. And like things like, how do we prevent cost overruns if this fully autonomous system is operating, sort of like without impunity? How do we ensure we have access to the best possible AI systems, regardless of like who wins the model race, who wins sort of the AI layer race, right? You've already heard, I think that last one did a good job of showing how much complexity there is in the vendor ecosystem, right? You don't really want to be making a bet on any one of these things. You just want to be building a system. So how do you do that, right? Also, how does the role of the human evolve in this new system? If you're not intervening as the signal flows all the way to deployed software, what are you doing, right? Well, I think that, and then how does that change the organization? I think that generally you should then be thinking, well, okay, if I'm not doing that, then I'm clearly somehow involved in building this system or maintaining, refining, or evolving the software factory. And that is ultimately the new role for people. And so if you're thinking about what does it mean for me to build, refine, or evolve a software factory, you should be thinking about a couple things of like, one, how should this system be designed? Well, we have a couple of opinions. The first is that you should be model independent, right? Like if you are operating in a world where you're gonna delegate your software factory to a single model vendor, and they're gonna make a ton of arguments that are actually not that compelling, but maybe they'll make compelling arguments that, oh, you have to verticalize aggressively and your agent harness needs to be with the model. We found like empirically that's like very clearly not true. You actually want to aggregate and commoditize that model layer in order for you to have access to the true Pareto frontier of both cost and quality, all right? And so then the second thing is who should own this? Well, we literally make SaaS to help you build this, but I still think that you should be in control of whatever software you use, right? And so we also offer things like on-prem, air-gapped, all the way to basically, you sign a contract and we throw it over and we don't see it again. And that is because we believe you should be the sovereign of your software factory. It's incredibly important that your software factory operates regardless of what vendors come and go, because ultimately your software factory is your company, right? If you build software, you're basically describing the new version of your business. And so it's really important that you're able to maintain and control that. And then the last is you should really be thinking about your software factory as something that operates across every action that takes place inside of your product and engineering organization. So if there is basically any activity, any context, any workflow, that's a part of your software factory. And there's a lot of stuff that you can do, right? Everything from code review to security analysis to testing, documentation, right? Incident response. But at the end of the day, each of these workflows should probably operate with effectively a shared agent core. Because I think that there was actually, I really enjoyed the talk just a bit ago that was talking about this idea of if you have like a ton of different specialized agents, like a code review agent and an incident response agent, you sort of end up in this weird microservice system where you're hyper optimizing each of those agent architectures for what is ultimately one sort of shared workflow, which is gathering information, acting on information on computer systems, and informing the user as it does that, right? And so you really sort of want this singular AI agent system where the context and the workflow changes, right? Code review is obviously a very different workflow from incident response, but ultimately it's actually at a high level, all just gonna be like computer control on top of the agent with context. So using a shared agent core to then operate across many surfaces that your software factory may touch is also super important, right? And in a larger organization, you're probably thinking about things like governance. How do we handle, consistency? How do we handle ensuring that, an agent doesn't go and like drop a bunch of tables, right? What about IT ops? A bunch of stuff like this sort of becomes very clear. I would argue that this is ultimately the responsibility of whatever agent platform you're using to enforce all of these standardized controls. And you really should be asking, is there a page called like enterprise controls or organizational controls, and how many are there, right? And if you're not seeing hundreds of different scenarios that an agent platform has gone through in order to basically refine preventing bad things from happening with agents, then I would just start looking out and see like what is out there. There's open source standards. Docker just came out with a really interesting sort of like 35 control system for this, where they said, what are the agent controls that you need inside of an agent platform, sort of vendor neutral. I thought that was like a pretty cool way of delivering that. And so then that sort of leads you to this next interesting point, which is that almost certainly after all this work of talking about agents, you've actually maybe not fixed the biggest problem that's preventing agents from succeeding, which is the state of your environment. And so I always like draw the analogy of human beings. We don't like, when we were 200,000 years ago, we're like not that different. We're pretty much the same humans, more or less, but we're so much more advanced. What happened? Well, we completely changed our environment around us, right? And so yes, you can wait for agents to continue to get better. They will probably continue to get better. But I think that really updating the code base and the engineering system around your software factory is by far the highest leverage changes that you can make. And really that's looking at things like dev reproducibility, environment cleanliness, linting, type checking, quality tests. Really, the actual sort of tidbit would be, what is the amount of, or like, do you have enough deterministic, verifiable feedback loops inside of your organization to give agents the ability to succeed without needing to consult a human, right? So it's one thing if you wait for code review to say that code is not organized well. It's much better to have a deterministic signal that says that code is not organized well, right? And agents can then use that to loop and validate their work until they succeed. So yeah, here's a laundry list of controls that matter, right? Security, governance, and enablement. All of these are super important. I don't want to like blaze through this, but I think it's like the type of thing where you can take a photo. Ultimately, my view is that your agents are going to have access, ultimately in the software factory, that is dangerous. It's just how it's going to happen. Like, it's not really a matter of if, but just when. And so you have to treat them the way that you would human beings, which is you build out systems of control and you build out layers, right? So how do you prevent a human from dropping an important table in your company? Well, you may be relying today on basically telling them not to do that, right? That is actually not good. And probably the analogy that if you've ever thought about building sort of software organizations for more than, say, 50 to 75 people, you start to realize that even 50 to 75 incredibly competent people, someone's going to eventually drop the database, right? And so you really have to think about introducing these agents as sort of scaling up the guardrails, prevention, et cetera, towards what an organization maybe 10 times larger than your current organization would look like, which is sort of interesting because if you're a 5-person startup, that means you're actually operating at what the controls that maybe a 50-person company would need. If you're a 50-person company, 500 people, right? And so you really have to up-level a lot of the guardrails and the systems that are actually very well established. And I think you don't really need to reinvent the wheel here. You should look at software development best practices and then just ensure that they're being enforced on those agents. And so on that idea, I think that this is like probably the most interesting and evolving part of humans' roles in the software factory. I sort of alluded to this earlier, but we've already just labeled a bunch of things that I'm suggesting that you change, right? This is what we're gonna do. We're gonna say, what are the guardrails that exist? Oh, there aren't guardrails for that. Let's actually implement the guardrails for that. We're gonna look at where agents are failing, and what are we gonna do? We're gonna add context. We're gonna update the workflows that the agents are following. A lot of, actually, like, if you've listen to any talks, and I highly recommend listening to talk about like chip fabricators or any of these really advanced like Industry 4.0 actual real life factories, you start to realize there's like whole dedicated roles of process control, process management, loop management of people who basically just look and say, okay, great, like we lost 10% of the resources due to this bad inefficiency. Let's go fix that part of the factory, and then we're gonna reiterate and sort of refine. We're basically gonna be doing that for software systems. And so I think a lot about this process of how do you observe failures in your software factory? How do you intervene when you are seeing either one, like a one-off, or two, a consistent failure, and three, how do you then refine iteratively those workflows? It ends up kind of, as everything does, boiling down to evals and verifiability. Like, how do you evaluate whether or not a failure happened? The case study here would be code review. Like, pretty much everyone in here who's thinking about a software factory, the first step you can make is building a system that makes you confident to merge maybe 5, then 10, then 50, then 100% of your PRs without human code review. What would that look like? What is that system? And that doesn't mean that you still don't need humans to understand the code changes. That's sort of a separate part. But ultimately, you probably need something like what self-driving cars had, which was, this is kind of dark, but like fatalities on the road. Like, everyone knows when the fatalities on the road drops below, and you know, the order of magnitude is kind of what's interesting. Maybe it's the same as humans, maybe it's 10 times less than humans, but there's some sort of metric where we go, great, we think this is safer than the humans, so we're happy to let this thing start driving. Similarly, with validation, you need to get to the point where you say, what are my metrics that I'm gonna measure to allow that review step to happen without a human in the loop? And maybe you feel that it's like bugs, maybe it's incident responses, incidents, maybe it's MTTR. Maybe you wanna look at a bunch of these things together and say, we think that maybe our system is now safer than humans being involved, so we're gonna let that thing run. And you should probably have engineers thinking about that inside your company. I sort of just alluded to this as well, which is, what are the outcomes then you're measuring? I would be looking at cycle time, I'd be looking at code shelf life, incident time, number of bugs that have occurred. Do not measure tokens. It really does not give you a ton of information or value. And so you can also, though, look at costs in other ways, maybe just like cost per code change, cost per like loop or per week, right? Almost treating it in a way that we do humans with salary. And those are the things that you can then measure and iterate and optimize against. So if you take 3 things away, it would be 1, invest in agent readiness. That is super important. We build a product for that, which is pretty cool. 2, govern before you scale. You want to implement all this stuff before you start immediately rolling this out across the whole company. And 3, you've got to be thinking about the outcomes that you want to measure in advance. Because I think the last deck just had this. You can't optimize against something that you aren't measuring. So really important to have all this stuff together. And hopefully this was helpful in thinking about building your software factories. Thank you.